on. So now, what's going on is we drop the solid into a pot, into a beaker of hot water, boiling water, 100 degrees Celsius water. So I know it's going to come up to 100 degrees Celsius. I'm going to make this solid really hot. Then I'm going to dunk it in a beaker of cool water. And that hot object is going to cool down. It's going to lose heat energy. So I can first of all calculate the amount of total heat energy it has. And then as it cools down, I'm going to find out how much heat energy it loses. But it turns out however much heat energy it loses, it's going to be picked up by the cool water. The cool water is going to gain the same amount of energy as the hot object loses. So again, I'm up to step 7. Notice that at this point, I have a little temperature probe sitting in a beaker of cool water. And when I hit next step, it's going to actually give me the temperature of the cool water. So notice I got this little brown line, and it's right around 11 degrees, a little bit over 10. So that's the temperature of my cool water. Now, when I hit next step, it's going to dunk my hot object, which is at 100 degrees, into the cool water. And notice what happens. When I do that, oh, the temperature of the water spikes up, because now I'm dropping a hot object into the cool water. The cool water is picking up heat energy, and it's increasing its temperature. So notice that now my temperature has jumped up. It went from 11, I've gone from 11 all the way up to, let's see if I can get oh, come on. From 11 all the way up to about 35. So my water has changed temperature. So the delta T, the change in temperature for the water, is the current temperature, 35, minus the initial temperature, which was 11, is changed by about 24 degrees. That's the change in temperature for the water. The change in temperature for my mystery solid, I'm going to put that as M. Remember, the mystery solid started at 100 degrees, and it's currently at about 35 degrees. So it cooled down. It went from 100 to 35. What's the difference there? 65.